So we've been talking about reciprocal trig functions. We have definitions of the reciprocal trig functions. And now what I want to do is I want to take a moment and talk about identities again. So I want to revisiting identities. And so we know some identities already. So recall that an identity is an equation that is always true, no matter what the variable is, right? And so we have some identities that we know. For example, cosine squared, sine squared is always 1. That was our first one of the first ones that we learned. There's also the definition of tangent. So things that are definitions are by definition always true, so they're identities as well, assuming that there's variables involved. And then we talked about symmetry identities, right? So for example, sine of a negative input, that negative can be pulled out front, right? That's equivalent to negative sine x. So this is odd symmetry, right? This is an ID as well. This is odd. And so I want to just briefly talk about our reciprocal trig functions now. And we're going to do this by using an idea. So an idea, we can create new identities from old identities. We can create new IDs using previously known ones. Previously known. So for example, is cosecant of negative x. Is this, we don't know yet, is this cosecant of x? Are these equivalent? And the way we can figure this out is, so essentially we're trying to ask, is it an ID? So is this an ID? And we can check if it's an ID by trying to convert it into stuff we know and then use old IDs that we know, right? So if we can convert this to an old ID, a known ID, then this also has to be an ID. And so the way we do that in this case is to just use the definition. So cosecant is 1 over sine. And keep in mind that whatever the input is, that goes with it. So it's 1 over sine of negative x. So the input follows. But now we're back in terms of something we know. We're familiar with sine. We're familiar with sine already. And we know that sine of a negative, that negative can be pulled out because it's an odd symmetric function. So this negative here can actually be pulled out front. And so this is then negative 1 over sine x. But then, what is 1 over sine x? 1 over sine x is cosecant. So this is cosecant of x, and that negative is out front. And so what we've done is we've gone from, right, cosecant negative x, that's what we started with. Cosecant negative x is equal to this, which follows this identity, which is then equal to this. So therefore, from this, we can see cosecant of negative x is indeed equal to negative cosecant of x. And so yes, it's an ID, and cosecant is also odd, right? So this is the key idea. We can either create new IDs from old IDs, or we can check if something's an ID by trying to convert it into an ID, right? So this gives us ways of checking lots of things. So let me go ahead and put out one more example. So we know something we know already that we've covered. We know that cosine of a variable plus a 180-degree rotation is equivalent to a negative of just cosine of the variable. Okay, so this is something that we covered already. Should be on your formula sheet. This is an ID. So this is always true, no matter what x is. So here's an example then. Is secant of x plus pi equal to negative secant of x? Well, if we look at the definition, secant is 1 over cosine, right? So this is 1 over cosine. Inside stays the same, x plus pi. And then we know cosine of x plus pi is equivalent to negative cosine x. So this is 1 over negative cosine x. Then 1 over cosine x, that is secant, and the negative's out front. So this is negative 1 over cosine is secant x. And so therefore we went from secant x plus pi over here, right, is equivalent to that by definition, which is equivalent to that by ID. And then using the definition again, we get this is equal to that. And so we say yes, it's an ID.